Good morning, everyone. Welcome to VSS Monitoring Sessions. And my name is Anna Dong. I'm your moderator for today. I will be in the background answering any questions that you may have. We will first start off with a quick introduction of our speaker today, and then we will move through the presentation as planned. This is a 60-minute session. 45 minutes is for the presentation. The last 15 minutes will be for Q&A. As we move through the presentations, I will be prompting you to enter any questions you may have so that we can answer them at the end of the session. You can do that by entering a question, clicking on Ask a Question on the upper left-hand corner of your screen. Okay, without further ado, I would like to introduce our speaker today. We have online with us here Gordon Beith. He is our Director of Product Management at VSS Monitoring. His extensive career includes over 25 years of work in telecommunication, product management, marketing, hardware, software development, and related next-generation services area. In addition to his work with VSS Monitoring, Gordon's background also includes product, project, marketing, and account management position for EneoQuest, Imperix, Spirent, Cisco, and Ericsson in global locations. Gordon received his BEE degree from Swinburne Institute of Technology, Melbourne, Australia, and also received advanced technical and management training at the Australian Institute of Management, also in Melbourne, Australia. And some of you may have known Gordon as the co-author of the book on IMS testing and monitoring entitled Ensuring a Quality IMS Experience, published in 2007. Without further ado, Gordon, welcome to the sessions, and all yours.
Well, thank you very much, Anna. Nice introduction there. Good morning, good afternoon, good evening to everybody on the session. I'm pleased to be able to do this session for you today. So this one's entitled Future-Proof Your Data Centers Network and Security Monitoring. So, a good place to start is actually to talk about the actual traditional methods that people have gone about in the past to obviously design their networks, but also to approach the monitoring of what's on the networks. So one of the issues around providing monitoring access into networks is around being able to implement changes in your network. And so that sort of means that, if you don't design things in from day one, then quite often getting changes implemented into the network to implement your monitoring infrastructure can be a challenge. And then furthermore, if you're not going to actually put something into the infrastructure itself, you may rely on the network equipment that you could have already in the network and rely on mirror ports or span ports that could be on those products to get copies of traffic to be able to monitor what's going on. You can often run into contention for getting access to those ports. You may not have enough of them, and quite often the functions of those ports are a secondary priority to the actual handling of the network traffic that those network elements really have. And then the complexity that can be introduced by trying to do the traditional methods of designing your networks with scalability, and then on top of that your monitoring abilities with scale as well. This also causes a problem. It's seen with passive monitoring applications, whether you're monitoring for performance or for security. But it's also obvious when you're trying to do inline active types of monitoring and threat prevention. That becomes even worse in terms of your ability to make changes and to scale your network as well as your network monitoring capabilities. And needless to say, if you're trying to get a good visibility onto what's going on in your network, then having access to the points that you need to get access to be able to get visibility into the traffic and the traffic at different points in the network, then obviously following the traditional methods of where you put the network in place first and then try and add your monitoring later does tend to be an issue. So when you're thinking about trying to break out from that traditional network design approach, whether it's thinking in terms of a silo method where you might just say, okay, I need to monitor for one aspect of, say, performance, whether it's just for the network itself, or it could be for an application, one specific application, or whether you're doing monitoring for various aspects of security. If you continue to think in silos, then that also means that multiple different organizations and different individuals are trying to get access to the same data, and because they're thinking and designing in a siloed manner, that means you'll end up getting not just port contention, but also contention for access to network links. And therefore, you'll actually be challenged in your ability to scale up, to actually implement your monitoring solutions quickly, and probably end up bumping heads a lot within the various network organizations. And further, what you run into challenges of trying to match network speed or bandwidth with the actual the bandwidth and capacities of the tools that you're going to use for doing your monitoring. Because whether it's a performance monitoring tool or whether it's a security monitoring tool, quite often they either have limitations in their throughput and ability to manage all the traffic, or quite often they might even be over-dimensioned for the actual networks that they're being connected to, in particular if you can only put them in one link at a time. So therefore, you get a mismatch between what your tools can handle and what your networks can actually handle. So I think this time is probably a good point to take a poll. Anna, do you have the questions there?
Yes. So please start your voting for question 1 and 2 by clicking on the vote button on the upper left-hand corner of your screen. We'll give it a few minutes so folks can get the vote in.
So which particular question are they voting on, Anna?
They are on question 2 now, Gordon, and just a few more minutes.
How often do they compete on network access? In other words, span access, or when adding inline security tools?
Exactly. All right.
Correct.
We're still getting a few more.
Very good.
Okay. I think the voting have stopped for a little bit, so let's view the results. How often do they compete for network access, span access, or when adding inline tools? We have 12% answering never, 50% answering sometime, 35% answering often, and 4% all the time.
Yeah, that's quite interesting, Anna. I think that matches pretty much with what I would have expected. I wouldn't expect everybody to to never have, I wouldn't expect most people to never have the issue, and I wouldn't expect them to have the issue all the time. But yeah, having most of the people seeing it sometimes or often is pretty much what I would expect. That's great. We'll move on to the next slide then. So this here, trying to show a network architecture from one perspective, which could be used for security and monitoring. So as you can see here, what we're trying to show in this picture is the devices that are sort of standing out on sticks. You can consider as passive monitoring tools, and the ones that are actually sitting on the network link, you can consider as inline active devices or appliances for performing monitoring, or they could be for other types of aspects as well, such as quality of service improvements. But from this perspective, we'll consider it as monitoring. So there can be a number of different devices, obviously, for different types of purposes, and trying to get access to the traffic on the same link or the same network segment can be a challenge. And not only that, for a single type of tool to see to get the full visibility of every packet associated with a session is also important. So that if you went with very traditional tools and a very traditional approach to implementing those tools, one tool may actually only see one side of a conversation, because with aspects such as asymmetrical routing, where the initial request message going out may follow a completely different path to the response to that request that comes back within the session, and so therefore even requests, subsequent requests could even go out on different paths, so that you don't really have control of that in networks today. So therefore, it's important to be able to see the entire session, to be able to do an adequate monitoring of what's going on in your network. So what we suggest here is to be able to make a better network architecture for scaling in your data center for the monitoring, is that you actually, instead of trying to think in terms of just trying to get your tools in place into the links that you need to get access to, you use an approach where you can put network packet brokers in the network. And the network packet brokers traditionally have been called a lot of other names in the past. They've been called intelligent aggregators, intelligent taps, aggregation visibility devices, a number of different names and terms. The term that's been adopted in more recent times is network packet broker. And the network packet brokers allow you to connect to the various links and segments that you need to get access to, and to bring all that traffic together into one or possibly more appliances that are sort of connected together, to bring the traffic into a consolidated position that you can then associate session, the packets within the same session, keep them together, and then forward that traffic out selectively to the tools that you need to get the traffic to, and only the specific traffic that those monitoring devices or security devices need to see. So if you have a product that's focused on, say, web traffic, then you only need to send them the traffic that you would that tool is designed to monitor. And as an example, obviously HTTP or HTTPS traffic. If a tool really is designed only to handle that type of traffic, then that's the only type of traffic you send to it. And if you have another tool that is, say, a quality of service analysis tool for voice over IP traffic, then the only traffic you would send to it would be the voice over IP traffic. And then further to that, if you actually want to scale, one instance of a particular tool could probably only handle a certain bandwidth, whereas with these network packet broker devices, they can bring together a large number of links from different points in the network, as also in addition to multiple segments, maybe on the same network, to give a total picture and comprehensive gathering of the data that you need. And so therefore the aggregate amount of data, even after selectively sending out only the traffic of interest, could still be too much for one single instance of any one of those monitoring or security analytics types of devices. So therefore, you can spread and split out the traffic using either selective filtering or using some balancing techniques to spread the traffic out to those multiple instances of the same tool to allow one tool type to be able to monitor and manage checking for security or analyzing the traffic for a complete session and for every single network segment that you need to look at the traffic on. And at the same time, it keeps all the session data together.